Dr. Daniel Mendoza is a research assistant professor in the Department of Atmospheric Sciences and holds joint appointments as an adjunct assistant professor in the Department of Internal Medicine, the Pulmonary Division, a visiting assistant professor in the Department of City and Metropolitan Planning, and the NEXUS Research Institute at the University of Utah. He is the co-director of the Consortium for Dark Sky Studies and serves as the editor-in-chief of the Journal of Dark Sky Studies and is the instructor in the Capstone Class on Dark Sky Studies at the University of Utah. Please welcome Daniel Mendoza, everyone.
Good morning, and thank you for the introduction. Thanks for the opportunity to present. Well, Alejandro, now I have another bucket list place to go to. That was a very inspiring video. Thanks for setting that up. I think that one of the things that we tend to forget, and you'll see how I'm guilty of this in terms of my work that I'm going to present in a minute, is that I focus a lot on urban areas. I think that's one of the places where we really look at, and that's and I think that we really need to start looking at the people that were there before us. And so what I'm going to do is I'm going to share my screen. Hopefully it works. Yep. So again, I'm Daniel Mendoza, and I'm at the University of Utah. I'm very happy to be living in Utah. We have one of the highest densities of dark sky places in the world, so it makes for a really great place to be studying this field. Here, as my image here, we have two areas. Many of you who are potentially not from Utah probably only know Salt Lake City. Well, Salt Lake City is part of this very sort of thin north to south band of land in northern Utah, which is home to about 85 to 90% of the population, depending on how you call the Wasatch Front or where do you define it. But this is, I think it's a fairly striking image. We're looking south from a town called Ogden, which is north of Salt Lake City. We can see the sky glow there of what we call the Wasatch Front, which would be on the west side. Here, as you're looking down, it would be on the right side, and you can see really that whole bubble there of light. Whereas the Wasatch Back, which is less developed, it's home to Park City for those of you who are ski enthusiasts. But other than that, it hasn't been as developed. However, unfortunately, in recent years, there's been this just great influx of people, and we're starting to see much more in terms of light pollution issues, and that's on the left-hand side of that mountain chain. And you can really see the difference in terms of just being able to look at stars from this vantage point. So again, as I mentioned, I'm going to be primarily talking about urban issues, urban lighting, and I like to put a little bit of a spin to this. Not necessarily because it's something that I had originally started to look at. Primarily, I like to look at spatial differences, temporal differences, but unfortunately, when we start to look at this and we start to kind of go down that rabbit hole of seeing where there are differences, we start to really see that almost everything that has been an urban development, almost any one of these variables, is really an environmental justice issue. But the way that I like to see it is an opportunity for us to grow and learn from this. So I'll very briefly talk about urban lighting. I think many of you are probably familiar with this, and if not, they're really great resources to take a look at that. I'll also start to talk about some of the lighting differences that I've started to analyze, and then unfortunately, we do have to get a little bit of a better hook in terms of when we try to change policy, when we try to really get the attention of stakeholders. And so for me, the easiest way to do that is to start looking at statistics in terms of traffic accidents and how they're associated with streetlights. And then I really wouldn't be here if it wasn't for really the advancements and what we're really trying to do in terms of educational development, which is the minor in dark sky studies, which is the first of its kind in the world that we've developed at the University of Utah. So I think many of you are familiar with this. It's the Bortle scale, and this is where we really look at the quality of the sky. Of course, when we're looking at cities and then the city sky, we really see that we really actually don't see stars. And then we start to look at dark sky sites, and then we start to look at really rural areas. That's really some of the ideal situations, the ideal locations for us to really be looking at the Milky Way to see constellations. So that's something where we're really trying to, of course, it's going to be very difficult to get from, say, 8, 9, or 7 down to where we can actually see even the Milky Way. I do remember some people, some of my friends who told me that about 30 years ago, you could actually see the Milky Way here from Salt Lake City. Fortunately, Salt Lake City is not necessarily as light polluted. I would probably say, if I were to guess, it'd probably be around a 6 or a 5. I still can see some stars, and actually was able to look at some last night. I joined the session. It was fairly late. It was about 11 p.m. My time. And I was able to go outside. I was inspired. I looked at some stars, but unfortunately, I do see the difference. Even in the 7 years that I've been here, I'm starting to see some sort of some really degradation in terms of our sky quality. So that's something that we're really looking forward to mitigating. There are many societal implications. I think we're very familiar with them, but I'll just briefly go over just 5 of them. Their health issues. The largest epidemiological study in the world actually was the nurses study, which looked at shift nurses, meaning people who worked on first, second, and third shift, and then second and third shift workers do have greater health implications, primarily associated with stress. It could simply be, again, we like to look at this and discuss it as an association, not necessarily a correlation, but there are negative health impacts with being a second and third shift worker. We tend to also think, and that's where some of the indoor lighting issues come up, where we start to think about, well, if all the light that you see, because you're a third shift person, that primarily would mean that you're sleeping during most of the day. That means that your exposure to light is primarily at night, and it's primarily artificial. We also need to think about economics. Any wasted light is really wasted money, which really means issues in terms of air quality and also greenhouse gas emissions. We have all heard, and that's probably how many of us were brought to this field, the ecological impacts on migrating species, simply the amount of confusion, the amount of issues that it does to many of the species, not necessarily migrating, but also even your local species. There's a false sense of safety, and that's the thing that we really have to battle often, which is where people think that better lit, or, well, not better lit, but more lit is better, which is not quite correct. Some of the brighter lights, and we think of, for example, some of the street lights, that really tend to look almost like floodlights. They tend to almost look like stadium lights. They're essentially punitive lights. They're generally found in lower income communities, but many studies have shown that more streetlights are not necessarily conducive to safer conditions. They could actually be associated with worse amounts of crime. The very simple explanation for that is, if we could somehow light up the whole earth like the sun does, which we really don't want to do, then it might potentially be safer. However, if we do have, for example, streetlights, and they cause this bright areas, but then in between you have this darker areas, it does cause some issues in terms of how your eyes adjust, how your pupils dilate, and whether you can actually see things in those dark areas. The example I always like to bring up, and I'm happy if everyone shares this, is when people are asking, well, what is the problem with having this giant lights? Well, imagine when you're driving on a highway at night in a rural area, there are not many lights at all, and then someone comes up behind you with and then they turn on their brights. You're temporarily blinded first by the light, and then when that light turns off when the car passes you, for example, because your eyes just won't adjust. And that's something that we really try to discuss with city planners, and discuss that these are issues that are affecting us really visually, and they're actually counterproductive to what the original intent was, which is to provide some sense of safety. And then the sociological aspect, and I'll discuss that more in a little bit later, is that people are missing the opportunity to connect. And especially through this past year, called the lost year, the COVID year, 2020, when people really lost a sense of connection, for example, many of us were homebound in a sense. We were able to work from home. We're actually encouraged not to go out and socialize with other people. And many people started to really question their place in the universe, and really being able to look up at the sky and saying the same constellations, obviously, as they shift throughout the year, and being able to see that we are all part of this universe. That does help ground people, and it does help encourage people to really think about what our place is, and that we're all part of this fabric. We're not necessarily an isolated species, which unfortunately tends to be one of the landmarks of Western culture. So what is light pollution? I think, again, many of you might be familiar with this, but because I am discussing urban lights, I wanted to just bring this up again. When we see a regular street light, the cone of useful light is not necessarily as large as we think. There's the glare, which is really unintended light that really shouldn't be going to our eye, for example. In this case, there's light trespass, which is light where it shouldn't be going. And then we also have the sky glow. That's what I showed on the first slide, where it looks like this bubble of light pollution. The other fact that we need to be thinking about is the color of light. Now, when we start to think about what we're used to, we're really being, the sun is really right around 4,800 K. That's what we would be, for example, right now, if I'm peeking out the window, that's really kind of the type of color that I'm seeing, and that's what our eyes are adjusted to. Now, there are many guidance on the color temperature, because many of you might be familiar with the blue light spectrum. That's not what we really want. We have night mode, for example, or blue light filters on our electronic devices, and they've been designed there for a reason. Blue light tends to excite us, gets us going, keeps us awake, and especially, again, a lot of my research, that's why I keep referring to this, a lot of my research has gone focused on COVID-19 year, so in 2020, and really looking at societal impact, and especially with the increase in screen use, that has been a concern, where people are up late at night just looking at their computers, and they've been the entire day through Zoom calls or some other type of media calls, and that amount of screen time has increased dramatically, again, because no one's really going to an office, or very few people are going to an office and really interacting with other people, and not needing to sit down at a desk for endless electronic calls. So those are some huge concerns in terms of looking at how our circadian rhythm gets affected, melatonin levels, and really what our light exposure is overall. This is a really nice rendering. I like to show it every single presentation. Is when we start to see this exposed bulbs on the left side, we can start to see those shadows. That's what I always brought up in my presentations. You can see how there are these shadows, and there are darker spots and there are lighter spots. And this is where, unfortunately, as people think, well, let's just add more streetlights, that does cause some issues. But then if we look at the right panel, that is more correctly wider and really lower intensity light. We can actually see less of that sky glow. We can actually see that the light is not going into people's yards or people's windows. The unfortunate part, though, is, as you can probably start to see, is that the colors were warmer on the left panel versus the right panel, which just seems more of a blue light spectrum. So I'll just dive into some of the analysis that I've done. I looked at some nightlight data, some satellite data, and what I looked at here was Salt Lake County. And those of you who are familiar with Salt Lake County, Salt Lake City is on the north side, and that's really the downtown area. That's one of our brightest spots. But then when we start to look down and we look further south, we start to think about, well, what could be there? That's still fairly undeveloped. You can kind of see that the southwest part of the county is less developed because, again, there hasn't been as inhabited. However, it's quickly developing, but what could be that bright spot? And it turns out that it's actually this conglomerate of, there's Costco, there are a lot of car dealerships there, and we also have the aquarium. What's interesting is that these hotspots are starting to appear in many communities, and not necessarily in the downtown areas. They're simply very commercial areas, and as you can see, they are the two brightest spots. So the analysis that I'm going to briefly share, because I don't want to make this too much of a math presentation, is really looking at the household income, the streetlight intensity, and then I'll show the crash data as well. So Salt Lake City is divided into really an east and a west side. It's not necessarily politically divided, but it's divided by the large highway that runs north-south across Utah, which is I-15. We can see it right here. And so the east side is generally wealthier, generally less ethnically diverse, and the right side is, I'm sorry, and the left side, which is the west side, is more ethnically diverse and lower income. So
5-minute marker.
Great, thank you. So on the west side, as I mentioned, there's a greater degree of diversity. And so when I started to look at the streetlight intensity here in watts, and then I looked at the demographics, we can see and here the x-axis is the percent of that particular demographic. In this case, is white population, and then on the y-axis is the streetlight power. And as you can see, that the more you have a whiter population, more affluent population, generally speaking, the lower the streetlight intensity. But then that starts to flatten out and actually increase when you're looking at Asian population, Hispanic population, going higher with a Pacific Islander population, Black population, and then when we look at American Indian population. And so what we really see is a demographic shift in terms of what we think in terms of the light that's available and the light that is there's really dispersed heterogeneously throughout the city. If we look at commuting behavior, again, we see that there's a difference between who drives to work, who walks to work. And we can also see the same in income. The higher someone's income is, or in this household income, the brighter the lights. So now we can see that when we're looking at poverty status families, that light intensity is much higher. What that really tells us is, again, is that whole idea of punitive lights, where there is an idea of spotlighting certain communities in the name of safety. However, that doesn't really do as much as in terms of safety as people think. I looked at the crash data as well, because that is a sense of safety. Now, again, total crashes by hour of day. You can see that during rush hour, we do see those peaks right around 8 in the morning and about 5 p.m. We do think, based on this, that maybe people really like to rush home as opposed to rush to work, and that's and people take more risks. This is all the crash data, and this is just to really show you the density of crashes as well as the density of streetlights that we have. So I've mapped every single streetlight here in Salt Lake City, as well as all the past 12 years now of crashes. And what I wanted to show is really the total wattage of the nearest light associated with all the crashes. And we can see that the lights, for example, for bikes and for pedestrians, specifically for bicycles and pedestrians, there's higher amount proportionately compared to the actual lights overall. What that means is that the brighter lights tend to obscure primarily pedestrians and cyclists. Those are the populations that I've been looking at, because again, motorcycles and cars, they tend to have their own lights. They have tail lights, they have other lights, so they can be easily identified. However, many people don't have bicycle lights, and many people don't really carry a flashlight. Some people carry a cell phone, of course, at night. But again, it is a disproportionate amount of accidents that happen on higher intensity lights. So the last bit of data here is the daytime versus nighttime accident severity. So what I did was I did empirical cumulative distribution, where I looked at the severity of crashes. 1 is least severe, basically no injuries. 5 is mortality. and then 2 to 4 is in between, essentially. And we can see how daytime, and that's the blue lines, have much lower incidences, or have much higher incidences of the lower severity, whereas the nighttime tend to shift more towards higher severity. That shouldn't be a surprise, but then we start to look at cars, motorcycles, bicycles, and pedestrians. We actually see that pedestrian injuries, again, if you look at lower lines on the lower amount of severity on the lower end of that, that means that those are less dangerous collisions. Whereas we can see that, for example, pedestrians specifically, as well as bicycles, those tend to have higher levels of severity. And this really kind of underlines the whole point here. And this is all statistically significant. I didn't want to put the p-values or anything like that because they're all statistically significant. And we can really see the difference that whenever you have a car and just another car, which is a blue line involved, and then bicycles and pedestrians, we see this substantial difference in terms of the severity of the crashes. So that's something that we're actually bringing up to stakeholders. I'm part of the city's transportation advisory board, and I'm bringing this up because it is a substantial issue. As discussion topics, just to prep the conversation for later, I wanted to just bring up the fact that, as I showed, lighting differences, there are significant differences across sociodemographic groups. The crash differences are statistically significant. And here's where I want to talk about the outdoor light, how it affects disadvantaged communities. First, occupational exposure. Higher fraction of second and third shift workers are concentrated in lower income communities, which means that streetlights are actually affecting them. We may think, well, we spend so much time indoors, I'm barely outside, except for many people who commute outside. It is an issue. Again, the perceived sense of safety, and lastly, cumulative effects. If you're being bombarded with this blue light and brighter light, your circadian rhythm gets thrown off, you feel you're awake, and then when you go home, now instead of grabbing, say, an apple, if you live in a community with better lights, which generally means that you're higher income, you probably then grab a candy bar because you're probably also in a food desert. So we need to really look at this holistically. And then the education and the ability to enact change. Many of these communities are not even aware of this. Just wanted to give a brief 30-second on the Dark Sky Studies minor at the U. It's the first of its kind in the world, like I said. Our visionary here, Stephen Goldsmith, was the one that really cranked this out. We got generous funding from the W.M. Keck Foundation to really get this started. And we've had some great community outreach work. That's us flying some drones there on the inset. And we've actually worked with lower income communities. Here, it's a Title I school. And we had some artists who helped paint a mural in the cafeteria to really bring awareness to these communities, because they may not even know what these issues are. They're obviously have pressing issues such as having a job, retaining a job, being able to put food on the table. So light pollution, while it's not something that's at the forefront of their minds, they are deeply affected by it. These are the main takeaways, and I look forward to our discussion later on. Thank you.